One of the best ways to understand the Earth climate system as a whole is to look into the Earth's past and to look at different time periods in the Earth's climate history when greenhouse gases were at different levels. How much of the difference is really explained by the greenhouse gases themselves, how much is explained by other factors. The ice cores are among the best records to answer those questions. We collect ice cores both from Greenland and Antarctica. These are the two biggest ice sheets in the world, and the two ice sheets that contain really very, very old ice. If we drill down to the base of the Antarctic ice sheet, in some places ice has been recovered that's as old as 800,000 years. And so we drill ice cores to get this ancient ice to look at the record of Earth's past climate.
I had a background in chemistry, and I kind of wanted to get a better understanding of the dynamic system of the Earth. We can learn a lot about the climate by looking at the air and the ice. We can learn about how wet or dry it used to be. We can learn about how cold or hot it used to be by just analyzing what geochemical proxies are in the air or ice.
What you're looking at here behind me is a system that will take large volume air samples that are extracted from the ice. This is a system that essentially is a major step in the processing of samples on their way to getting measured for carbon-14, for getting these answers about questions like the past solar activity.
Just recently we returned from an expedition to the center of the Greenland ice sheet. We were outside of Summit Station, and this is one of the most remote sites in the world. The question I get the most is, how cold was it? The first night we were there, it got down to -40, which is the same in both Fahrenheit and Celsius.
What we have here are boxes of ice cores from our recent expedition to the summit of Greenland. This particular set of ice cores is going to be used for carbon monoxide analyses also. These ice cores will get us back to about the year 1800 AD, so to the start of the Industrial Revolution, and we'll be able to really see the full history of carbon monoxide in the Northern Hemisphere and how it's changed over the course of the Industrial Revolution.
What we're really trying to do is just get a better understanding of the changes that we're observing on the planet. Because this climate change is not black and white. The Earth is a very dynamic system, and we can't study it in place, so sometimes we have to look back at proxy evidence and indirect evidence to gain a better understanding of how the Earth has been changing.
It's very important to understand how the climate system works so that we can predict where it's headed, and so that we can with confidence predict what are the conditions that would cause the system to really spin out of control.
A production of the University of Rochester. Please visit us online and subscribe to our channel for more videos.